Hello and welcome back. Let's have a look at what question we've got today. Here it says find the equation for each of the following hyperbolas if they are of the form y equals a over x minus h plus k. Now let's just recall that the h value is equal to the x asymptote and the k value is equal to the y asymptote, and a represents a dilation or a reflection if it's negative. And let's just have a look at a few of these. Now the h and k, sorry, let me come back to that. The h and k, you might have seen that in turning point form. And turning point form of a quadratic, for example, will be y equals open bracket x minus h close bracket squared plus k, where h and k, let me make that a bit clearer, h and k represent the x and y coordinates of the turning point. So here they have a very similar function. Here they represent the x and the y asymptotes of the hyperbola. So let's dive into 9a. Let's see, we've got a h value here, h equals 2, because on the x-axis that asymptote is at 2, and the y asymptote, whoops, that's k, that is 0. So let's sub into our general equation, y equals a over x minus 2 plus 0. Now we don't know our a value yet, but luckily this graph is giving us a y-intercept. So if we sub that intercept in, what's that? That'll be 0, negative 1. If we sub this x and y value in, a will be the only unknown left over. So let's try it out. Negative 1 equals a over 0 minus 2. Negative 1 equals a over negative 2. Let's multiply both sides by the negative 2. We get 2 equals a. Nice. Now, let's sub all that in. We'll get a equals 2. So we'll have y equals 2 over x minus 2. And remember, we want an x and a y in our equation. Otherwise, we'll just get something that says 2 equals 2 or 1 equals 1, which isn't very useful. So that's a done. Let's have a look at a slightly more complex one now. Let's look at E. E looks quite nice. So our h value, that's 4 to begin with. We can see there's a vertical asymptote, and it crosses the x-axis at x equals 4. And the y-asymptote, k, that'll just be 2. So let's sub that into our general equation. Y equals a over x minus 4 plus 2. And again, we need an x and a y value to sub in. That would leave a as our only unknown, and then we can calculate a. So we've got two options here. We've got 1.5 on the y-axis, or we've got 3 on the x-axis. Personally, I'm in love with that 3, because dealing with fractions, and you already got a fraction here, ugh, don't even bother. So let's use that x-intercept 3, 0, and sub that in. So y equals 0, a is still unknown, x is 3 now, minus 4 plus 2. Let's do some rearranging, get the a by itself. Let's get rid of that minus 2. Sorry, that plus 2 by doing minus 2. That'll equal a over negative 1. Multiply both sides by negative 1. We get 2 equals a. That is a coincidence. Our a values are both 2 for this one. Now, let's have a go at subbing everything in. What do we get? We'll get y equals 2 over x minus 4 plus 2. And that's it. We're all done. So we can see the general form of a hyperbola, y equals a over x minus h plus k. H and k just represent the x and y asymptotes. A can be a dilation or reflection, depending on the value of it. Reflection if it's a negative value. How did we solve these? Well, we had 3 pieces of information really. We had a x asymptote, a y asymptote, those are our h and k values, and we also had coordinates. We used x-intercepts or y-intercepts to find the a value. Once we subbed those in, we could solve for a, and then finally sub in a to our general equation, and state a final equation. So let's list that. What did we have today? We had 3 pieces of information. So step 1, 3 pieces of info. We had the h value, we had the k value, and then we had an x int or a y int. Step 2, sub in and solve for a. Finally 3, state the equation. And that's all we've got time for today. Thanks for joining me, and I'll see you next time.